Hey, geometry, lesson 17 here. We're now going to talk about side, angle, side, and side, side, side criterion for two triangles to be similar. Please note, I said similar and not congruent. We've already done that. We don't need to do it again. Okay, first of all, opening exercise. Choose 3 lengths that represent the sides of a triangle. Draw the triangle with your chosen lengths using construction tools. It's really hard to do on an iPad. So there's my triangle with chosen lengths copied from an earlier exercise. We're going to pretend these are all centimeters. It's probably not too far off. Okay, part B. Multiply each length in your original triangle by 2 to get 3 corresponding lengths of a side for a second triangle. Draw your second triangle using construction tools. We are multiplying by 3 because that's what I already have ready. So that's what we're going to use. Okay, there we go. They're not necessarily to scale next to each other, but the measurements are correct. So if I multiply everything by 3, my new triangle is 12, 6, and 15. Do your constructed triangles appear to be similar? Explain your answer. Yeah, they do. Okay, they look the same. The angles look to be the same. My ratio is 1 to 3. The angles appear to be equal. So yeah, they appear to be similar. Do you think that the triangles can be shown to be similar without knowing the angle measures? Maybe. I bet we're going to learn throughout this lesson. Okay, exploratory challenge number 1, which also doubles as our first exercises. So here we're going to get the opportunity to discover the side angle side criterion for similar triangles. We're going to look at a triangle that shares an angle, and we just need to make sure that the sides in this criterion do not mean that they're congruent. It means that they're proportional. The angle has to be congruent, but the sides have to be proportional. Cool? All right, so examine the figure and answer the questions to determine whether or not the triangles shown are similar. So first of all, what information is given about the triangle in figure 1? We know that angle A is common. They share that angle, therefore congruent. We also are given information about some sides. That should be common, sorry. So angle A is common, and we know some side measurements. How can the information provided be used to determine whether triangle ABC is similar to triangle A, B prime, C prime? We know that similar triangles are going to have the ratios of corresponding sides that are proportional, so we can check that. We can check the corresponding sides for a common ratio. All right, let's compare the corresponding side lengths of triangle ABC and triangle A, B prime, C prime. What do you notice? So it looks like I have, if I do the little triangle over the big triangle, that'd be 4 over, not 9, but 4 over 13. And let's check the other side. That would be 3 over, not 6.5, but 3 over 9.75. Okay, let's find the cross product. Make sure that if I multiply down, I get the same thing. 4 times 9.75 is 39, and 3 times 13 is also 39. And if that checks out in the middle, then the lengths are proportional. So we have side and side and angle in between. Based on your work in parts A through C, draw a conclusion about the relationship between triangle ABC and triangle AB prime C prime. The sides are proportional. The angle are equal. Therefore, the triangles are similar. Okay, examine the figure and answer the questions to determine whether or not the triangles shown are similar. Okay, we have a common angle. It's P, not B. So that's going to be equal. Now we just need to check the proportions, the ratios of the sides. So if I get 3 over 13 and see if that equals 2 over 9. Let's do the cross product. 2 times 13 would be 26, and 3 times 9 is 27. Not equal. Therefore, the triangles are not similar. Oh, but we have questions to answer. Sorry, let's look at that. What information is given about the triangles in figure 2? We have angle P is common to both. And we have some side measurements. I jumped the gun again. How can the information provided be used to determine whether triangle PQR is similar to triangle PQ prime R prime? Well, we can check the ratios to the corresponding sides. Compare the corresponding side lengths. I already did, I'm sorry. Let's do 3 over 13, which is the left side of the triangles, and then 2 over 9. Find the cross product. 27 and 26 are not equal, therefore they are not similar. Based on your work, draw a conclusion. See above. At this point, we've gone over enough material to prove the side angle side similarity criterion. So I just want to call that out. If we have sides that are proportional and an included angle, it must be included, that is congruent, the triangles will be similar. Cool. Here, this challenge is going to give us the opportunity to discover side, side, side similarity criterion. So let's just look at this first one. Examine the figure and answer the questions to determine whether or not the triangles shown are similar. All right, first of all, what information is given about the triangles in figure 3? The only thing that's given is side lengths. How can the information provided be used to determine whether triangle ABC is similar to triangle A prime, B prime, C prime? Well, we're going to have to check the ratios of sides, and we can't always assume that the sides are corresponding in the right order, but we can check the proportionality of the sides. On this example, it does give us the order ABC and A prime, B prime, C prime. That should have a prime in it too. So we are going to check them in those corresponding sides, but we won't always know that. So sometimes we're going to have to check like the long side with the long side and the short side with the short side and then the one in the middle. Okay. But let's go ahead and compare the corresponding side lengths. So A to B, I have 1.41, A prime, B prime, 2.82. That looks like a factor of 2. Let's check B to C prime, 3.5. And then BC is 7. That looks like a scale factor of 2. And then that last one is going to be 2.7. So we're A prime, C prime over 5.4. I can simplify all these pretty easily. It looks like I have 1 over 2. You could also cross product them, and then you check the first and the last and make sure you get the same cross product. But this one's pretty simple. I can reduce each one of those fractions to 1 over 2. So we're good. Based on your work in parts A through C, make a conjecture. These triangles are similar because all the sides are proportional. Okay, examine the figure and answer the questions to determine whether or not the triangles shown are similar. Let's just go ahead and check the ratios, okay? We're going to go through the steps. For this one, if I look ahead, it does say ABC, A prime, B prime, C prime, so let's check them in that order. A to B is 1.41, A prime, B prime, 2.1, BC, 6.04, B prime, C prime, 8.29, and then AC, 5.25, A prime, C prime, 7.28. Okay, I just checked the first two ratios, checked their cross products, multiplied down, and didn't get the same answers. I could also just do division, 1.41 divided by 2.1, which gives me 0.67 and a bunch more numbers, and then 6.04 divided by 8.29, which gives me 0.728 and a bunch of numbers. And please realize, if you round and get the same answers, but they weren't the same before you rounded, they're not the same. Rounding gives you enough error that just makes them not equal. Okay, here we answered these. We're good. And we answered these too. Okay, we have exercises 5 through 10. I'm going to go through them pretty quick. You can check a few things and check your answers, but you don't need to go through all of these. You may have figured out what we're doing just by the exercises that we've done, or the examples we've done. So you can sit back and enjoy the ride, or check your answers for a few, or just move on to the problem set. Okay, here there's no information about angle measures, so we just went straight to checking the sides. They're not similar because my ratios are not equal. Proportions are not equal. Here I have an angle, and the angles are equal, so I'm going to go ahead and check the sides. Okay, here the angles are equal, and the sides are proportional. So I've proved similarity because of side angle side. Are the triangles shown below similar? explain. If the triangles are similar, write the similarity statement. Those angles are equal. So angle B and angle D are equal. And then they share angle A. So yes, they are similar because of the angle-angle similarity criterion. Okay, number 8. Are the triangles shown below similar? Explain. It looks like angle A and angle E are equal. So let's check the sides. And again, I'm not sure which one corresponds with which. Let's just do big side over big side of one triangle over big side of the other, small over small. These are not proportional, therefore not similar. I should also point out that we could have found the hypotenuse using the Pythagorean theorem and checked side, side, side. Oops. But since we knew two angles were, oh goodness, how'd that happen? Since we knew two angles were equal, I went for side angle side and proved that it didn't work. Okay, number 9, are the triangles shown below similar? We don't know anything about angles, so let's go ahead and check the sides. And like I said earlier, if we don't know what order the sides are in, we just check the largest side of one triangle with the largest side of the other. Oops. And then I go straight for the smallest, 3.6, smallest of one side, smallest of the other, and then what's left over. 7.28 over 5.46. Hold on, let me do some math. Okay, I just reduced each fraction and got 4/3. So yes, these are proportional. Sorry, these are similar because of side, side, side similarity criterion. Are the triangles shown below similar? Explain. Well, I see we have vertical angles, so that's sort of nice since they only gave us two sides. So let's check the sides. 2.24 over 4.48 looks like a 1/2. And then 3.16 over 6.32 also looks like a 1/2. So they're similar because of side angle side similarity congruence, or sorry, similarity criterion. And that's it for today. Good job.